Okay, we'll start chapter 4 with right triangles. Main thing in this section is going to be solving right triangles and then also looking at applications, mainly the angle of elevation or angle of depression type problems here at the end of the section. But when we solve a triangle, basically what that means is that we're going to find the lengths of all three of the sides of the triangle, and we're going to find all three measures of the angles in the triangle. So by the end, we'll know the lengths of all three sides and we will know the measures of all three angles. Now, when we're dealing with a right triangle, one of the angles is automatically going to be worth 90 degrees. So the two smaller acute angles are going to add up to be 90 degrees. So angle C is always going to be the 90-degree angle. And so the other two angles are going to add up to be 90. So they're both going to be acute angles. And then to get the lengths of the sides of the right triangle, we're going to use a Pythagorean theorem. A squared plus b squared equals c squared. And the right triangle definitions of the trig functions: opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. So again, capital letters we're going to use for angles, lowercase letters we use for lengths of sides. And always the lowercase a is across from angle A, lowercase c is opposite angle C, and lowercase b is opposite angle B. And so we're going to solve these triangles using the Pythagorean theorem, and we're going to use the definitions of the trig functions and the fact that the sum of the two acute angles is 90 degrees. So here is a right triangle. So we know the length of side B, we know the length of side C, and we know angle C, but we don't know side A, or angle B. So let's do first the side A. So A squared plus B squared equals C squared. Well, A squared is going to be 11 or 12.1 squared minus 11.4 squared, because I can subtract B squared from both sides. And so A squared, when I plug that into my calculator, 12.1 squared minus 11.4 squared is 16.45. So side A is the square root of 16.45. And so when I take the square root of that, I get 4.05, and the units are centimeters. Now, that gives me side A. Now let's look at angle B next. So angle B, if I notice, I know the length of the side opposite angle B, and I know the hypotenuse. So opposite over hypotenuse, by definition, is the sine of that angle B. And so 11.4 over 12.1 is the sine of B. So the sine of B is equal to, and again, that's just the definition of the sine, opposite over hypotenuse. So 11.4 divided by 12.1 gives me 0.94215. And so angle B is the inverse sine of 0.94215. So angle B, second sine, 0.94215, gives me an angle of 70.4 degrees. And so if angle B is 70.4, then angle C is going to be 90 degrees minus angle B. So that's 90 minus 70.4. So angle C, not C, angle A, not bad, that's angle A, not angle C, sorry, is still 90 minus 70.4, so it's still 19.6 degrees. And so I can just check by adding 19.6, 70.4, and 90, and that adds up to be 180. And so that's how we solve a right triangle. So let's do another one. So this time I know two of the angles and one side. So the first thing I'm going to do here is find out the third angle, B. So angle B is going to be 90 degrees minus angle A. So that's 90 minus 37.34. So angle B is going to be 52.66. Sorry. And so now if I know angle B, I can find side B. Side B is adjacent to angle A, and C is the hypotenuse, so B over C, adjacent over hypotenuse, that is the cosine of angle A. And so side B is just C times the cosine of A. So that's 11 times the cosine of 37.34 degrees. And so in this case, I plug that into my calculator. 11 times the cosine of 37.34. And that gives me that side B is 8.75 inches. And so now I know C and B, I can use Pythagorean theorem to find A. A squared plus B squared equals C squared. So A squared plus 8.75 squared equals to C squared, which is 11 squared. So A squared equals 11 squared minus 8.75 squared. So A squared is equal to 11 squared minus 8.75 squared. And so we get A squared is 44.4375. So that means that A is the square root of 44.4375. And so A, second x squared, 44.4375. And we get A is 6.6666 or 6.67 inches. And so now again, we know angle A, angle C, angle B, and we know side A, side B, and side C. So we've solved the triangle. And so one of the applications of solving right triangles is talking about problems that involve something called the angle of depression and angle of elevation. So essentially what the angle of elevation is if you're looking straight ahead, that's the horizontal, that's the horizon. If you're looking at something up above your head, above the horizon, you have to tilt your head up a certain angle to see that thing that's above you. Well, the angle that you've made by tilting your head up is called the angle of elevation. And in the same breath, if you have to look down to see something, the angle that you go from the horizontal to look down is called the angle of depression. And so angle of elevation is what you get when you look above your head. Angle of depression is where you're like standing on top of a cliff and looking down below. Okay, so we're going to look at a couple of examples of this before we move on to something else. So angle of elevation, angle of depression. So here we go. First example, flagpole problem. So we got the angle of elevation to the top of the flagpole measured by a digital protractor is 20 degrees from a point on the ground that's 90 feet away from the base of the flagpole. So we're going to find the height of the flagpole and we're going to round to 2 decimal places. So I kind of drew a picture here of what we've got. We've got our person here that's looking at the top of the flagpole, and that's a 20-degree angle to the top of the flagpole. And he is standing 90 feet away from that flagpole horizontally. And so X is the height of the flagpole. So we can use a trig function to find out what X is. X is the side opposite the 20-degree angle. 90 feet is the side adjacent to the 20-degree angle. So we've got opposite over adjacent is equal to which trig function? Opposite over adjacent, that's the tangent of my angle. So in this case, X over 90 is the tangent of 20 degrees. And so if I multiply both sides by 90, I get X equals 90 times the tangent of 20 degrees. And whatever that is, when I plug that into my calculator, that's the height of the flagpole. So I type in 90 times the tangent of 20. And I hit enter. And I get that the flagpole is 32.76 feet tall. And so that's how we use this solving ability of these right triangles to find out the heights of things given an angle of elevation or an angle of depression and a distance that we are away from said object. Okay, so that's the flagpole problem. Now the next one is a little bit more complicated, but still kind of the same situation. So in this case, we've got two observers that are 5 miles apart. So this is observer A and this is observer B, and they are 5 miles apart, which in feet is 26,400 feet. How did I get that? Well, there's 5,280 feet in a mile, so 5 miles is 5 times 5,280, which is the 26,400 feet. Okay, so they're 5 miles apart. The observer closest to the plane has an angle of elevation from the ground to the plane. The plane is up here. That's my plane. Their angle of elevation is 71 degrees. And observer B, the one that's farthest from the plane, has a 39-degree angle of elevation. So I want to find how high the plane is, the altitude of the plane, the instant that the two people observe the plane. So here's what I got to do. I've got to break this 5 miles down into two separate distances so that I can figure out the altitude of the plane. So I can split this large triangle up into two right triangles. I've got the triangle here that is this piece, and then I have this triangle that is this piece. And they both share a common side, right? So A is the common side that they share. So what I have is essentially two different triangles. I've got this triangle here from observer A to the plane with a 71 degree angle of elevation. I don't know the altitude. Do I know what this distance is? Well, I could just call this distance from observer to directly below the plane. We could call him X. And so if I have the second observer, the second triangle, again, A is here. There's angle B, and this time we're at 39 degrees. And again, the plane is there. Well, how much is this? If this piece is X and the whole distance is 26,400 feet, then if I take away X feet for this piece, then what's left is 26,400 feet minus X for the length of that side. And so what I have with this triangle is opposite over adjacent is equal to the tangent of 71, and over here, opposite over adjacent is equal to the tangent 39. So in other words, A is equal to the X times the tangent of 71, but it's also equal to 26,400 minus X times the tangent of 39 degrees. So can you see where this is headed? If I've got two different things that are equal to the same thing, then can't I say that X times the tangent of 71 is equal to 26,400 minus X times the tangent of 39? And then if I solve for X, then I can figure out what A is, because I have this nice little formula here. So I put the altitudes equal to each other and I solve for X. So what do we get? We get X times a tangent of 71 degrees is equal to 26,400 times the tangent of 39 degrees minus X times the tangent 39. So I need to get on my X's on one side. So I add X times the tangent of 39 to both sides, like so, to get all my X's on one side of the equal sign. And now I can factor out that X, and that gives me tangent of 71 plus the tangent of 39 is equal to 26,400 times the tangent of 39. And so X times all that is equal to that number, then I can divide both sides by the tangent of 71 plus the tangent of 39, and that'll give me what X is. So X is equal to 26,400 times the tangent of 39 degrees divided by the tangent of 71 degrees plus the tangent of 39. And so this I need to plug into my calculator. And so 26,400 times the tangent 39 is equal to 21,378.298,476. And the tangent 71 plus the tangent 39 is equal to 3.713, or it's 3.7139949. And so x in this case in feet is going to be 21,378.298476 divided by 3.7139949. So that's going to be 5,756.146. So that's x. That's feet. And so now that I have x, the altitude is x times the tangent of 71 degrees. So that's 5,756.146 times the tangent of 71 degrees. So I plug that into my calculator and I get 5756.146 times tangent 71 equals 16,717.06 feet. So that is the altitude of the plane the instant that both of those people observed the plane. And that is how we solve right triangles and how we solve problems that deal with angle of elevation, angle of depression.